viewing, then it's not a big problem. But for instance, if any of you says something inside our discussions here, and the author sees it, then that can sink your career prospects.
Oh,
No, unfortunately, not a single video that I shot went viral. I was hoping like maybe 1 million.
Trust me, you don't want that.
I want that because I want to have.
If that happened, I would have to ask you to take them all down.
Yeah, and I'm curious of what the university's policy would be on it.
As long as he gets student approval, it's in this gray area where it's okay-ish. If he doesn't have student approval, then it's outright academic dishonesty.
But is recording student presentations, sure, but recording your lectures.
I don't care.
I know for you, but the university, is it allowed to publish publicly university courses? That's A, not published from the university, and B, not.
That might be a legal gray area. Yeah, I don't know.
And also, the university does not make any money.
So the issue there is the fact that they're not the ones publishing.
Yes.
It's okay possibly that it gets published, but because it doesn't go through them, there might be an issue. I don't know.
Also, I don't know if what their stance on having public access to the just giving their courses away for free.
What about the audio recordings? Are those publicly available? I mean, it's not entirely the same.
Oh, I don't know.
I know that you can make audio recordings available.
That steps into an interesting gray area with legal side of things, because you have to make it very absolutely known that you're making audio recordings too.
Yeah. Yeah.
But,
I mean, that's one of those things where you have to notify people taking the class.
yeah. So you can take video recordings. Fine. Public, yeah. Audio recording? No. Like security cameras are illegal to take audio recordings.
Yeah.
Which is great, but bizarre. Yeah, like security cameras can't record audio. It's illegal.
Okay, what about Dropcam? Dropcam, have you heard about this? Wi-Fi enabled, essentially it's a security camera.
If it's in your house, then yeah. But if it's publicly seen, if it's in the public.
That's the key difference.
well, it's public administration.
No, because okay, sure. Because I'm from Russia and they're recording like, all these dash cams and no one cares.
And that's actually, that's not really, I mean, driving in Russia, that's pretty much required. you want that. That's how you survive as a driver. Or
The insurance company.
yeah. Yeah. So just as recap, while things are potentially getting connected to wireless or what have you, whatever weird things we have going on in networks. Again, reminder: the third assignment is up. I don't know if people have taken a look at it, but it is up.
I didn't see that it exists.
Okay. Okay. Yes, it does exist. I added some more to the template so that there are some more things that kind of guide you through a good way of doing stuff. So hopefully that will be helpful. Your solution only, I mean, the difference between the template and the solution that I had was about 240 lines, a little bit less. So, I mean, again, there's not a whole lot necessarily of code going into it. But sometimes...
That kind of limits your ability of using that.
So.
Okay. So.
Does anybody have a MacBook?
So I have your. I can get your presentation on here.
Oh, you can use my laptop. Is it a MacBook? No, but it worked the first time.
Okay, that's awesome. Did you have your PowerPoint?
My PowerPoint?
Yeah.
Yeah. It's
Okay.
a peep. I can scroll up and down.
Do you have the VBA board on here? Yeah, you did your presentation.
Yeah, she did.
I'm just coming.
One of those requirements for any laptop that I buy is that it has to have VGA and hopefully
These days even they are giving only Wi-Fi, they don't even give. These days they don't even give HDMI, they just give Wi-Fi.
I try not to go for a lighter weight laptop, which is more likely to have that issue. Get something a little bit bulkier, and you've got more likely to have something that's
It's on
functional.
my Gmail.
But then it's
Yeah, but it feels weird.
To
show you, I want you to show you.
I don't put a bulky laptop.
I totally understand that, but you want something that gets the job done.
It's true, and my laptop, which I love, and I don't want to give it up, is very bulky. So,
You have this HDMI to VGA converter. One is LAN port and one is HDMI.
Does
That's something.
HDMI carry the VGA signal on it?
Yeah.
So, you can get HDMI adapters for tablets.
Okay.
I wonder if it would actually output to a VGA.
It probably would. In terms of video, it probably would.
I don't know.
Because HDMI usually is split as both the video and the audio in one thing.
It shouldn't be bad just to get another adapter, right? You're looking at daisy chaining these adapters.
Yeah, but that sometimes does not work, basically. I don't know if this would put out an analog signal.
It's just a question of the complexity of the adapter. I mean, you could have an adapter that's a little bit more complex.
No, that actually converts the
Yeah.
digital signal to analog. Yeah.
That sounds like a pretty bulky,
Yes, it does.
Yeah. Well, it just, like, using a tablet for a presentation? Because, like, it's not, you're not doing anything other than going tab.
Sure. Since we have a little more time, additional reminder, again, ideas for projects.
makes sense.
Yeah. Ideally, we want some kind of proposal next week. I think I moved the official deadline back to next Thursday. And again, remember, they can be group projects, that's okay. Group in the sense of pairs, again, not in the group in the sense of all of you. But yeah, I'll maybe flesh out something a little more in depth about what's going on into those. I guess I ought to do that. But in general, if you can frame a problem, saying, here's something that I'd like to do, and here's something that I think, here's some actions that might take me toward that. That's reasonable. Back is a downright sensible place to have that connector. Not very common anymore. Like, if you've got it on the side, then there's a good chance that you're gonna have to switch to one side or the other. You're gonna have to, it's just messy. Sometimes you have these tiny podiums, though.
Oh, that's small.
So what would engineering be like if they actually make sense when they come up with design?
Yeah.
It's more about the placement, not where.
What happened? It was working up until like.
Are you wanting to use that projector? What do you want to do?
No. What am I doing? This is not. What? So, how should I make this work?
It should work automatically.
Did you do Windows P?
Windows P?
Can I do?
It's fine.
Windows P.
Is it?
And
What's
then
running?
you want to.
Windows?
Yeah.
That's it.
Go get it.
It's weird. So it's suddenly it stopped showing anything. Okay, what if you will figure it out? Will it turn
They're
blue?
still on?
Oh, that could be it. Does it need to be turned on? Again?
It's turned off. So it should, before it was blue, no signal, it switched off.
Would they be
Or
that
some-
stupid? Would they actually be that stupid? Would they turn it off remotely?
Probably.
Used in the beginning?
Probably.
But there's a
They're probably.
turning. So should I turn it on with that switch?
Can you?
Yeah.
Is that?
Just have to.
There's a button.
Okay. Yeah, in the other room there isn't even a button, at least that I saw. Or,
This video might get viral.
Go get it.
it's viral in terms of the way of improving the infrastructure.
I feel like we're missing a key part of the
That's how many we have to call tech to get them there.
There's no on-off button on this
I
side.
understand, but
Is it light on?
Yeah, it's on.
Okay, so the light's on.
Alright, now we have to do this.
That's ridiculous.
We tried already, Tyler. For some reason, I have no idea. It was blue. Apparently, it didn't get signal for the long time and just turned itself off. I might suspect it's because they expect, okay, if you are showing the video presentation from your laptop, they're gonna do it. If they don't get signal, they turn it off automatically.
The idea that you have to start from the get-go with your presentation on the screen, and I mean, that seems bad. That's kind of stupid.
But
It's because some of them use, actually, you see, using blackboards.
Well, I mean, I like to use whiteboards too, but you know, maybe spending a few minutes at the beginning of class talking is an okay thing to do sometimes.
No. Okay, call AV.
Yeah, we have to call it.
The light's on, right? Did you say the light was on?
It might just be on standby.
it's actually on just standby.
Oh.
The standby light turned on, but it's not actually on.
I could print the PDF and use that one.
Print it?
And then
Yeah.
We,
There, it's blinking green.
what is?
It's
okay,
turning
maybe
on.
they have to.
Now it's working.
Is it?
Yes, yeah.
Okay.
Started it remotely.
It actually takes that.
Well, I'm actually impressed that they can do that.
I see that Sony.
I was kind of impressed by that too, but it's still asinine.
Yeah, but I guess that's what that little box does.
Well, thanks for the call.
Yeah, well done.
What the hell?
Who'd have thought?
Asking for help.
This is totally unnecessary though.
But then this is not the slide.
If they just put like a remote in the room so you can turn it on and off at will, then that makes sense. Have it bolted down like they do in some of the other rooms.
Oh,
Also, it's on.
I don't think they plug it in, have power, so.
Have something on top of the projector, so yeah, maybe it's a little hard to get to. It's got a way.
They call AV. That seems like more work for AV too. Create more work
Yeah.
for yourself.
well,
But you better not want to talk at the beginning of class.
They didn't even ask me which room it was.
They know. They can,
They can tell where you call from.
yeah.
It's always interesting when you call from the next room over, and they're like, I don't see a problem in your room.
so the golden implementation driven software development.
You may be able to make it full screen.
F11.
Okay.
Software debugging tries to explain the failure of a test T in a program P and reports the buggy fragment of the code, which is basically the bug report. So here's the definition of a golden implementation. Golden implementation is basically the functionally equivalent program to the program that has a bug. It is the way that the program with a bug is supposed to behave. It could be an evolved version. For example, if there is a bug in a version of a program and then they get rid of the bug and produce a new version, that could be the golden implementation. Or it could be a totally different implementation of with the same specification. For example, it can have different data structures. This paper, contribution of this paper is a method that simultaneously applies dynamic slicing and step-by-step weakest precondition calculation in both buggy program and the golden implementation. This would gives us, as they claim, gives the logical explanation and root cause of the error. Also, they can so they're pinpointing bugs in BusyBox utilities, and the golden implementation is that they're using is GNU core utils.
Dorson, may I ask, could the golden implementation also have bugs?
Oh, so the assumption, they have this assumption that it's usually not very difficult to come up with an implementation that is bug-free, and that's golden implementation.
Another thing, I have a question. So, in regarding golden implementation, can we consider browsers like Internet Explorer, Google Chrome as a kind of golden implementations of the VCC3 standards? Or
You could. One way of thinking about this is that if you have one implementation that behaves correctly for a particular input, then you could use it as a golden implementation. So it's not even that it has to be correct in general, which might be a harder thing to guarantee. But if it's correct for a single input of interest, which is maybe something that causes a failure in a different version or a different implementation, then you could use that correct version for that input, or the version that's correct for that input as a golden implementation.
So why this? So why their approach is not? So why their approach, the debugging method is new and it's something that is worth publishing? As they claim, it's because it's not feasible by other debugging methods. For example, delta debugging analyzes changes only across program versions. However, we cannot assume that CoreUtil and BZBox are different versions because CoreUtil has different data structure compared to BZBox. And why we cannot use Darwin? Because Darwin is suited for errors that are exposed by a difference in control flow. However, failing tests in BZBox and CoreUtil followed equivalent paths.
So we should maybe mention what they're referring to in this context of delta debugging. They're citing one particular delta debugging paper out of a massive number that use delta debugging for different purposes. And the specific use of delta debugging that they're looking at here is one that looks at changes over source code history and trying to analyze which changes are responsible over the history of a program for producing a new bug. And so that's why they're talking about this one is only relevant with respect to program history. Because the version of delta debugging we saw in class it's attacking a totally different problem.
So the new, this is the architecture of the new debugger. It basically has 4 components: trace, collection, slicing, and weakest predicate computation, weakest predicate comparison, and the last one is mapping to source code. Now I'll go through each of them. Trace collection executes P. Basically, what this component does is executes P and golden P with input T using, is it TEITEM? TEMU.
Yep.
Using TEMU execution trace content.
Has anybody heard of QEMU? Like QEMU?
QEMU is
Yes.
in Android they use.
They use it in Android. It's just a general virtualization platform.
Oh, yeah.
Yeah. Okay, so now it's more familiar. This is just a version of that can do some additional constraint analysis. So it's a virtual machine that has this power to collect constraints.
What TMU does, it executes traces that contains all the user mode x86 instructions, which are non-privileged instructions compared to kernel instructions, and input-dependent instruction operands. So also at this stage, instruction traces are converted to semantically equivalent IR to be used in other components. So based on the user input information recorded in the instruction trace, this step converts variables directly dependent on the input to symbolic variable. So after this step, we can have the value for the output that we can use for other components. This section also identifies identifies the slicing criteria and maps it into IR level slicing criteria. I will define what's slicing criteria.
So let's take a step back and try and think about exactly what this is doing at a higher level, because it's easy to say here's what we're getting. It's important though that we understand just what these things are and what they mean. This is kind of low level. What about high level? So how does this relate to the techniques we've already seen? Any thoughts?
We're just trying to collect the error trace or no?
Yeah. I mean, we are just collecting the error trace and then building up a symbolic abstraction over it at a high level.
For both the code implementation and the web program.
Right. So at a high level, that's a fine summary. Collecting the error trace, building up a symbolic abstraction, doing it for both. Good.
Slicing criteria includes the output value V, whose value differs in two programs, and the slicing point. So it has a slicing criteria is an abstract with two components. One is the line number where the value V is output, and the value V which is the output of the two programs with different values. Slicing criteria is basically the first step to characterize the difference in behavior between execution of P and golden P. It's the first step to start dynamic slicing, the initial point of dynamic slicing. It is also used to find the, so I'll explain later. For example, in this example, what is the slicing criteria? So here, what does these two program does? The one on the left, the one on the right, the one on the right. The one on the right is the correct version. It outputs HW, and the name for HW is default HW. But the body one has segmentation, but because HW is not. And so at printf, one of them outputs null, one of them outputs the default HW. So these are the outputs and the value are different. So HW would be the slicing criteria variable, and the line numbers are 26 and 17. Examples. So now that we know slicing criteria, let's go to the next component, which is backwards dynamic slicing. Backwards dynamic slicing takes in a trace W and a slicing criteria L and out. Out is the variable and L is the line number. During a traversal that starts from L and terminates when we reach the beginning of the program, so we go backwards. Backward dynamic slicing keeps three components. One is the dynamic slice, so please remember, if you can, ABC. So A is the dynamic slice, which is the set of statements that have affected the value of the output in the trace. B is a set of variables whose dynamic data dependencies need to be checked. And C is a set of statements whose dynamic control dependency needs to be checked. I will explain each of these things, just the categories.
In general, this should make sense, right? Because that is just, those are just the dependencies in the program dependence graph that we would close over in order to complete the slice, right?
And this is the very quickly backward slicing algorithm. For basically each statement that we encounter, we do two things: data dependency checking and control dependency checking. For the data dependency checking, let V be the variable defined by the statement. If V is in the group of V, which is the data dependency set, remove V from B and add variables used in the statement to B and add a statement to A and C. If it is control, so now the second one is checking control dependency checking. If any statement in C is control dependent to the statement that we encounter, we remove all the statements from C that are control dependent to that statement, and add that statement instead to A and C, and add variables in statements to B. We'll see an example.
So just at a high level, do people have a picture? Well, do people have a picture of what was going on there at a high level?
If I say the example, maybe it would be clear.
I'm hopeful people, the example will concretize it in a very clear way, but I'm hopeful that people already know enough that you should have, coming into this paper, already had an intuition for what that previous slide meant. Hopefully.
I think so.
Okay. So you can vocalize this, I think so.
No.
Go ahead.
You can try.
And do you want me to go back to the
Sure. We'll go forward again as we.
to the algorithm, right? Or
Yeah, this is fine. This is good.
Well, starting from the error, taking a slice back through the program.
Okay, that much is very, very true. And this is just showing the actual algorithm for it.
Yeah.
So this is just that propagation of things that are relevant. So it's a linear scan backward through the trace.
there is a marker.
Oh, I've got markers too. So we've got a whole bunch of instructions in the trace. And this is just a linear scan updating the slice and growing it outward as you traverse backward through these elements. So if you had some dependencies here, then, if your criterion is here, then you'll add this thing and you'll scan back to the next statement. You'll scan back. Eventually you reach this and say, this is in my set of stuff I'm observing. And so you keep scanning back until you get this thing, because that was determined by this. So it's a thing that you're observing as well. And you'll keep scanning back until you get this, because it's a thing you're observing. So it's really just maintaining one set. They separate these things out based on data dependencies and control dependencies. Fine, great.
It's
But-
basically dependencies.
Yeah.
Whatever affects the.
So basically it only keeps anything that's dependent.
Yeah, that's it. You just, a
Depend-
big set of anything you're dependent on, and you just update it as you go backward. So it's a lot simpler and more standard than they're presenting it.
So are they running it like twice because it's a dynamic trace? So first they run the program, then save all the state at each execution, at each statement, and then they traverse backward from the down.
That's what the trace gives you. Right? So they run it once and they record the trace. And the trace just gives you all of that information about dependencies, tells you all the pointers that were encountered. Right? So this should have been pretty obvious. I think.
Trace is like just an instruction, right?
Hmm?
Trace is just an instruction which got executed.
The trace should not just be the instruction that got executed. It
Yeah,
should
in
also
this case it
include,
should be the states also.
to a limited degree, yeah.
So do I need to go through the example? If it is obvious.
It's okay. It concretizes things. I think it'll make the other parts, the examples later, clearer.
Okay, so so as I said, backward dynamic slicing starts from slicing criteria. That's the initial starting point. We know that, so for the program on the right, which is the correct version, at line 26, HW is data dependent to line 25. So 25 is added to dynamic slicing. And then 25 is control dependent to 24. So 24 is added to the slice. And then 24 is data dependent to 11 and to 9 and 4 and 3, which is basically the definition of the function and the return value. Same thing for the program on the left, which is the buggy version. So
none of this should strike you as surprising.
now that we have all the components that we need, information that we need, we go to the next component, which is computing weakest precondition. So what's the weakest precondition? We know what's the weakest precondition, but weakest precondition is computed based on, first we need to know the post condition. Post condition is basically the condition that has to be true, has to be true after execution of a fragment of a code or whole code. So here, for example, in my example, the post condition would be HW for the program on the right, HW is not null, and for the program on the left, HW equals null. That's the post condition for variable HW. So based on the post condition, we set the post condition and use a slicing criteria to set the post condition, which is, for example, that, and then compute weakest point only along the dynamic slice trace. So one thing that they're claiming they're doing that is good in this paper is that they don't compute weakest point along the whole trace, only along the dynamic slice, which is instruction that affect the output, the variable that we want to, the error place, the observable error. So we don't have to like take into.
This is going to become very relevant when we discuss the related work. So I think it's good to have an intuition of that, and maybe we'll draw a quick picture or two that illustrates it succinctly. How does this relate to some? This is essentially a way of computing a condition that represents the program's behavior, right? Or that represents some notion of computing this failing value, right? That's a big picture way of looking at it. It's one way of computing a condition that represents the failing value. We've seen other ways of computing conditions that represent program behavior as well, right? So what other techniques have we seen that did that? Maybe when we started testing, we're looking at testing techniques. Dart.
Yes.
Right. So we looked at dynamic symbolic execution. This is very much related to that, but it's different. It's different in some substantial ways. How did we compute that condition?
You're using a solver.
Well, that's how we solved the condition. How do we compute the condition?
Flow of the program?
Yeah, so we essentially executed the program, and then as we execute a new statement, we'd see how to reframe how to derive new constraints for this added statement. So in this forward direction, we'd add some new constraints. This is a backward slice, so we're doing something a little bit different. We are computing the constraints in a backward direction. And this affects the meaning of things. It affects how you're able to tell which things are relevant, like you just mentioned. And it also affects kind of the complexity, which I think maybe you're going to get to. I don't remember if you look at the rewriting rules, where they talk about how you update the constraint based on right, where they talk about the WP and Q and whatnot.
Covered almost. I tried to cover it almost every time.
Okay. So we're going to see that have a big impact in a moment. Or see how that frames things in a moment.
So compute pictures on the dynamic slice, this would have less computation, as I said, and it's simpler. So this is the algorithm, what they do for every. Actually, I talked about the algorithm here. so the weakest WP algorithm. For every statement encounter, we update the current. Is this what you were talking about? We update the current WP. For every statement that is related to our variables that we want to track. So we basically check data dependency and control dependency. For a statement of if the statement that we encounter is of the form x, for example, equals to e, we substitute e for all the occurrence of variable x in current WP. So we have current WP. We keep that current WP. And then for control dependency, we only conjoin the branch condition with the current WP.
So there's a big difference here between what we saw in Dart, or between essentially any forward symbolic execution technique, where for those forward symbolic execution techniques, you can get by just adding these new conjuncts to your condition, right? Because essentially every time you define a new variable, there's some constraints that apply to that variable, and so you just tack them onto your condition, right? In this case, when you go backward, you learn new constraints for the variables you've already got. In terms of new inputs you didn't know exist because you discover them as you traverse backward through the slice. Those dependencies become apparent. You didn't know they existed. And so you have to do this through substitution instead. It's one of the key differences in this backward approach. You've got to use substitution instead of just this adding of conjuncts.
So when we were doing the forward approach, we didn't know about these dependencies. So
well, in the forward approach, you do know everything because you can see the variable get defined, and so you can make all the constraints for that variable at that point where it's defined in terms of everything you've already seen. And so you can just tack on new conditions. But in this case, you see this variable x, but you don't know what constraints apply to it. So then, as you traverse backward, you have to, if x was used in 5 different constraints, then the way in which the new constraints you learn as you traverse backward affect those existing constraints you found have to be fed in through substitution.
Okay, so there would be a problem because then we have to, again, look into the whole WP to find the substitute, to find the occurrence and then replace them.
There is an issue there, but that's just part of slicing. But you can manage it with some relevant data structures.
This is the example.
So is it not more complicated because
Yes.
slicing actually knows the unrelated data bus, unrelated constraints because they are coming from the top to the bottom. But if you go from the bottom, then you don't know what constraints apply to it, so you can't really slice up everything.
From the bottom, you do know what constraints apply because you have a search, you have a slice criteria, and so that narrows your search space backward. So there are trade-offs. The overall size of the constraints that you are involving will be smaller because you don't have to build constraints for everything. But you do have to do a little bit more work at every step in order to maintain this updated knowledge as you learn new information going back. So there are trade-offs. It's not a clear thing one way or the other, but for their purposes, they want information about the failure. And so building all the other constraints aren't helpful for them. In fact, they pollute their knowledge. So the slice is better. It's worth it. Okay.
So here's an example for how the algorithm that I explained works. So initially set the first step we set initially set the post condition as HW for the program on the right. HW is not equal to null. This is the post condition. Then for which comes from the slicing criteria at line 26. And then we know that based on the slicing information that we have, that line 26 is data dependent to statement 25. And since it is a data dependency, we replace HW not equal to null to get HW type default HW. And then again, based on the slicing information that we have, we know that this 25 is control dependent to 24. And then what we do at this step, we only conjoin the statement with the current WP that we have. So I missed that. Conjunction with HW set equals to 0 and also RV equals to H. And then at the next step, we don't change the WP anymore because nothing is dependent to our HW anymore.
Okay.
We have no data.
So I think big picture here is just building up a constraint, a precise constraint that represents a notion of what was relevant for semantically leading to this failure. What constraints over the input represents the outcome for this variable. And so let's take that big picture and move on with how they use it so that we can get to the results.
So WP comparison, now we have two WPs, one for the golden implementation and one for the buggy program. Now, each of these WPs are a set of conjunctions. So we basically compare them. We compare them and it's very simple. We just see if one constraint doesn't exist in that one and we report that constraint as a bug. So there are some issues here that usually WP could be very long and keeping that huge WP might be troublesome to each time compare each constraint with the whole thing. So they do pairwise comparison, which is constraint to constraint. But that so if each of them if the length of each of them is n, then that would be ON2, which is time consuming.
If you look at this in terms of kind of the high-level semantics again, so we've got one constraint from one of the programs, we've got one constraint from another one of the programs, right? And it's just saying that if there is something inside when we look at the expansion here, if there's something inside this formula that isn't implied by that thing up there, then this represents some logical difference in the way the value was computed. If you can find a difference in the way the value was computed between the two different programs, then that difference in how something was computed in its value indicates something that could have been one of the differences that led to the bug. And that's it. That's the big picture. And then this thing just says, well, doing this implication check, pretty tough. So instead, they just do a pairwise comparison, because this is just a whole bunch of these as well, a whole bunch of conjuncts as well. So they just do a pairwise comparison between all of them, saying, for any one of these smaller conjuncts, can that one conjunct imply the other conjunct in both directions?
And the last step is mapping to source code. So, so far,
I think we can move on past this one because it's pretty obvious. You can just, if there's some conjunct, you can just keep track of where that came from.
Yeah.
Right. Okay.
Just report the location from the source code. Now, limitation of this approach. They experience with libpng the buggy version and the correct version. One thing that happened was that they had 18 and 19 constraints which were related to 9 and like 10 lines in the source code. But all these constraints were not actually bugs that they were reporting. They were not actually bugs. They were just difference in execution. So one problem with this method is that they generate some unexplained constraint as bug report, while they're just due to difference in implementation. They also have a scalability issue because of the size of the dynamic slice might be, because the size of the dynamic slice may be large. This leads to large number of WP constraints, and then scaling is a problem. Also, the false positive characteristics. The method reports two set of for example, if you see these two statements, y greater than and equal to 5, conjunction with x greater than y, versus x more than and equal 6. These two are actually semantically the same, but their method would report these two constraints as two separate constraints.
Mm-hmm. And this is because they have this shortcut, right? They don't check for general implication, they do this pairwise comparison as an approximation, which is fair in terms of efficiency. So I think one of the things that we want to do quickly before we discuss related work, or before we discuss results, is that there are a few different techniques. The previous technique to this one was called Darwin. And what that did, in contrast to this, is looked at just path conditions. So that was more like Dart. It did forward symbolic execution to build up constraints. And what happened then is that if you have two inputs that potentially lead to different results, right? Then if you get a path constraint from one, you get a path constraint from another. You compare their path constraints, and if they take different paths, then the constraints that are relevant for them taking different paths will identify a logical difference. It identifies different classes of inputs based on their paths, the paths they take. The problem that this paper looked at says that, well, it's possible for two different inputs to follow the same path, but one of them still produces a different result because the data dependencies are relevant. And so that's why they took this approach and extended and said slicing and use slicing instead. The added benefit is that it's possible to have a control flow graph where this condition is irrelevant to the result of a value here. You're using x, but x was set somewhere up here. So this condition is irrelevant. And one of the things that was mentioned was that slicing removes this constraint from your weakest precondition, whereas the previous Darwin approach could have included it if you weren't careful, right? Because it's still in the path constraint. It's just not in these sliced weakest preconditions. So it's a very small semantic change to the previous work. And so, but it still has an impact on things. One of the things you can get from this is that you shouldn't focus on having an optimal result in a research paper. You should focus on having something that produces value. And if you've got something that adds value, it's just another paper on top. So you can get multiple publications out of things, even with small changes. And this is how science works. There are lots of people who get hung up on publishing things with the view that they have to have the right way of solving something in the beginning. You don't. You want to have something that is an incremental improvement. And this incremental improvement will let you get feedback and let you see how things work in practice and tell you how then to make progress toward the right thing. Part of the reason why this is important is because usually when you start out on a research project, you have no idea what the right thing is. In fact, you pretty much don't, because you don't know what the problems are until you have these incremental versions, which is exactly like software development, right? You have these incremental processes and these stages of software development because your requirements change over time, and research is the same way. You don't know what the actual requirements are, what the actual problem is, until you've tried a few times with these failing versions that lead you to the right result. And this is a good example of that, I think. Okay, after we've harped on research process stuff, let's talk about these results. in the time
So
we don't
this
have.
is the result. For one thing, one thing that I forget to mention is that so WDP constraints after elimination they use tautology. So if two constraints are the same, they just remove those constraints, and so that's the size that goes smaller after removing.
These two numbers are the golden and then the test order.
This is for busy Bob.
He's asking about the angle bracket
Yeah,
notation.
the numbers between the angle brackets.
Yes, ish. I think that's true. Let me double check, but I could.
That's what I'm assuming.
Yes.
Okay.
That's what I thought, but I should double check. Unless someone else wants to jump in and say just definitively yes.
Yes.
Okay, I'll take that.
What did you say?
He asked about the representation in the angle brackets. You know, there's a pair of numbers.
Yeah. What the pair actually means.
Yeah, I believe you're right, that one is from the golden implementation, one is from
It also is kind of important which one's which. But,
less than you might think.
my question is in the lines of code when it goes to 0. Because if you have no lines of code in your bug report, that's not a very good bug report.
Unless it's entirely explained by lines of code in the other version.
So,
Right. So it's one of the things that this is doing is comparison, right? And so some statements from one version are relevant, some statements from the other version are relevant. And so if only statements from one version are relevant, great. That just simplifies things.
true, yeah.
So before you all head off, because we are out of time, it's good to get a picture of the nature of these benchmarks. This is an embedded benchmark. In fact, they say, you know, it's 100,000 lines, roughly, something like that. But really, every one of these is tiny, right? I mean, if you look at, yeah, these are not, it's 100,000 lines in aggregate, but every one of these things is basically independent. So you have to be careful about how you read those things. One of the reasons it's important that they're looking at embedded small benchmarks like this is because this is one of the scenarios in which this approximation is more likely to work. The constraints are a little bit simpler, it's more likely to work. In more complex applications, where the logic can be more complex, where the different algorithms used to solve a problem could be more complex, the notions of these false positives are even greater. So that's something to think about. There's something else that I want to talk about too, in the time we don't have, which is their comparison of regression bugs in the context of libpig. Okay, so we're out of projector now. But they did this comparison on libpig, where they looked at a buggy version and then the new version that fixes that bug, and they compared those two things. And they found that, oh, they could identify the fix that way. What do you think about that?
If you do a stiff in a Linux machine, it will tell you the lines which are different.
And for the way they set up the benchmark, that's exactly the issue. If you compare the buggy version against the version that fixes it, the differences will capture the fix. Period. That's the point of the new version. And it also means that the constraints that capture the new version will be much simpler and easier to identify. To actually do an appropriate comparison of identifying and explaining regression bugs, you have to compare the version that fails against a prior working version. And that's the only useful experiment there. So it's a very nice setup that they've got for that. It's very convincing unless you dig into the underlying explanation of that. I think that their regression story is not a strong one. Their other stories are interesting. Their embedded story is strong. Their regression story is kind of misleading.
What do you mean by regression story?
Where they're looking at libpig, where they had one version that was buggy, and then they looked at comparing that buggy version versus the fixed version. And they used this as a proxy for comparing the buggy version against a prior working version. But those are not the same thing. If you compare against the new fixed version, the difference will capture precisely the fix. And one of the reasons this is a big issue is because you're very likely to introduce bugs when you add new features. And this means all those constraints from the new features will also show up as bug reports. They're just new features, they're correct, potentially. So it's a very, very carefully done but not very meaningful experimentation on the regression portion.
Oh, actually, they had the assumption I forgot to mention about that. The golden version would have the same variables, output variables as the buggy version. So
Same output variables, but if you look at the way in which these that notion of golden version doesn't hold in the regression test case. Buggy output variables is okay. The issue here is the implementation with respect to those output variables and how they are computed and why they are different.
and they mentioned that so because they couldn't.
Yeah. So I'm happy to discuss this more, but I mean, if people want to leave, that's okay.
I will stay.
Peer pressure. Yeah.
Everyone's showing their head and looking at
It's that great academic crack knowledge. You know,
I have
everybody
work to
struggles.
do, TA hours and so on. So.
Sure.
That's a good excuse.
I beat.
My question though is,